Hello everyone, welcome to the fifth in our series of marine tech webinars. My name is Chelsea, I work for Plymouth City Council and I'll be your host for this event. Just a reminder that during this webinar you will only hear myself and our presenters speak. You will not be able to see or hear any delegates. After the presentation we will be holding a Q&A session. Please use the Q&A chat bar to ask any questions throughout the presentation. If you see any questions you'd also be interested in hearing the answer to, give it a like and this will send it to the top of the pile. Just a reminder, this webinar is being recorded with the intention to be available to others on demand. Enjoy, and I will now hand you over to Steve and Erin from Plymouth University.
Okay, hello. Thank you, Chelsea, and hello everyone. Thank you for joining us. If you are joining us live on this very warm, sunny day, otherwise this will be available, as Chelsea said, for people to stream. My name is Steve Rice. I work for the University of Plymouth and also for the Marine Business Technology Centre, which we'll refer to as MBTC. My role with the university is to effectively create connections between the industry and the teaching and university, the teaching and research we have. To create mutual opportunities for benefit, and that's where this project comes in. We're going to be covering USV Cetus, the open platform for marine sensing and remote operations, in today's presentation.
Good morning, everybody. My name's Aaron Barrett. My role is as the autonomous vessel technician here at the University of Plymouth. My role is to work alongside Steve to put into practice the ambitions of the project. So I run the vessel, do all the policy surrounding how it's operated, coordinate all of the support structure needed, and actually run the trials. Okay, now we've got about 30 slides to get through in 30 minutes today, so we're going to try and do this as quickly as we can, but as we said before, it's available to re-watch and restream, so if anything's too quick then hopefully you'll be able to catch up later. Quick look at the agenda. So what we're going to do is I'll talk through the MBTC project itself, give us some context and the nature of our funding that allows us to provide this offer. We'll also touch on the market opportunities and autonomy, why autonomous platforms and technology is such a good opportunity for the marine tech industry, particularly here in the South West. Then we'll get into it about the USV Cetus and get into some detail. Give you a few examples of the work we have been doing under this project so far, some great local innovative businesses. Then we'll get into the next steps and what you need to do to engage and get involved yourselves. And we're hoping, as Chelsea said, there's a section at the end. We're going to try and aim for about 15 minutes of questions and pitches. We'd really like people to provide their ideas. Obviously, we understand that not everybody, for confidentiality reasons, may want to do that in the public forum, but we'll obviously provide contact details so you can follow up with us after this presentation. Okay, so the MBTC. This is a project that's been funded by the European Union. It's monitored by the UK government. This funding, as you can see there on the slide, about 4.5 million, has really allowed the City of Plymouth and its partners, listed on the bottom of the slide there, to provide a really good wraparound offer of support for innovative companies. Each of the partners has a slightly different role on the project, but we all share the same mission and approach of meeting companies, understanding their needs, and seeing what we can do as a cohesive group of organisations with significant facilities and expertise to take their ideas or their innovation journey forward. And for the purpose of this presentation, specifically in the University of Plymouth with the USV Cetus. I can't go much further without mentioning Smart Sound Plymouth, but I would strongly urge everybody watching this presentation to check out the Smart Sound Plymouth webinar that was delivered earlier this summer by James Fishwick, the director of Smart Sound. And that is available now online, and so I won't spend a lot of time talking about this, but only to say that it's important to mention that all of these attributes in the bullets are really important elements of the waters locally around Plymouth that make a difference in terms of how easy it is to use platforms like Cetus and how easy it is to get into marine applications of technology if you haven't had any touch on it before, or if you have, how to de-risk and lower the significant cost if you have some experience in doing it through using the partnership. I will also say that there was an MBTC overview
webinar also delivered earlier this year, which is available, which with Rob Watson, the director, has provided. So I'll hand over to Erin now to talk about the opportunities in using autonomous platforms.
So yes, a very brief overview as to why we might want to look at uncrewed and autonomous vessels. What is it about this technology that provides some kind of opportunity for companies and organisations looking at doing marine work? This is a large topic, so I'm just going to skim over the surface. But effectively, autonomous and remote systems are all about doing more with less. They're about trying to increase your capabilities with the same assets that you previously, same funding and same support structures that you previously may have had. It's about faster, better, cheaper, to steal the NASA acronym. Autonomous and remote systems can increase your coverage of an area very, very, very dramatically. They can give you greater endurance. You can stay out at sea for longer periods of time. You can integrate those systems far better with other nodes within a network, what we call systems of systems. They give you enormous improvements in data quality, especially when you're doing surveying. These small, agile, robotically guided craft can do far, far better than a human being in terms of executing a survey. The data sensing can be, far better, largely because you're not always retrofitting sensors into craft that they weren't designed for. You can build really, really well integrated systems that work at a push of a button. You don't get that when you say charter a vessel for a few days and have to kind of, ad hoc improvise your sensor mounting. Also, they give you sustainability. You can make these craft smaller, you can make them faster. That means you can look at alternative propulsion systems. You can have more efficient designs, or you can have recourse to electric power, for example. Indeed, for the long offshore duration vessels, can be completely green in terms of their energy systems, using solar and wind, what have you. And it's about the 3 Ds, removing human beings from the dirty, the dull, and the dangerous. This is especially true for defence applications, for example, but also in things like offshore wind. They're often pretty inhospitable environments. Get people out of that position, get people out of that location, gives you great advantages in terms of, cutting the number of incidents at work. You're unburdening humans, and as I said at the beginning, you're doing more with less.
Brilliant, thanks, Erin. And just to kind of touch on the more pertinent example at the moment, particularly for Southwest, a specific industry opportunity is offshore renewable energy, as Erin said, wind farms. So wind farms, both in the traditional sense and the sort of forthcoming developments around floating offshore winds. There's a lot of global attention on this, but actually quite a lot of regional attention. There's a regional opportunity for the Southwest specifically around the potential for a Celtic Sea floating offshore wind farm. You can see in these 3 phrases here, there's really an emphasis. We obviously need to increase as by a large factor the amount we're sustainably exploiting the ocean resources, but to do that and to do it in a way that's cost effective and all the things that Erin just said in the last slide, you really need to rapidly increase how much data you are able to not just capture, but how you're able to process it, get it back to shore, deal with it. And the new technologies to do this need to be basically reinvented from the large giant offshore vessel scale to unmanned craft scale. So that is an important driver for everything we're talking about today, and to bear in mind whether you're already in the marine sector or whether you're looking to marinise the technology you have. Just as a quick example, and I don't expect everyone's going to have time to read every single line here, but the gist is, this is the current breakdown of costs for a 1 gigawatt wind farm. So the data cost per item roughly. Now, obviously, when we talk about USV Cetus and talk about these uncrewed platforms, there's a lot of complementarity in terms of how much you can fit out and do potentially simultaneously. These could be completely separate contracts for separate suppliers done with specific separate crews on manned vessels at the moment. You can see the lineup of efficiency and cost there. So a really great opportunity. Okay, so we'll get into the main focus of this presentation now, which is all about Cetus. This is a lovely shot here taken just yesterday on survey. We'll go. I've got 2 videos to show you quickly. They'll run concurrently, and then Erin will take over into the technical.
I think this vessel adds significant capability to what the university can offer, both for scientific research and for commercial development. It gives us a capability that we didn't have before, that really opens up new areas of activity across the board. I suppose you could say in some ways this is what I'd almost call a Goldilocks vessel. It's just the right size. Some of our manned vessels are quite large, which is useful for some activities, but also increases the cost and makes it more difficult to deploy in certain circumstances. There are other autonomous systems, but then they tend to be smaller, down at sort of the drone level, which again means they wouldn't be capable of certain activities that we can do with this craft. So it fits right in the middle, giving a capability that you don't have at either end of the spectrum. And for us, it sort of almost completes the set of what we need to deploy in pretty much any circumstance. From the student's perspective, this vessel will allow them to undertake projects, particularly with certain kinds of measurements, that would be much less reasonable to do without it. And from a research perspective, it really is the ability to gather data in a different environment over a different timescale at a very different cost point. So it really opens up possibilities we wouldn't have without it. I think the business community have a great opportunity to do certain kinds of investigative research that they've just not been able to do before. Again, it's a matter of having a vessel with the capability of this one. We'll let them test out various new pieces of equipment. We'll let them look for certain kinds of data to support their kind of commercial activities at, again, the right sort of cost point, the right capability. So I think there are all sorts of opportunities, some of which we're aware of and actively working on, and others of which will emerge as the community realizes the capability we've now got. Plymouth really does have the capability at every level, from the natural environment with the National Marine Park, through the smart sound with the capability we have for instrumentation measurement, right up to the capability of the kit we have available, the facilities we have to use it, the scientific expertise, the commercial understanding of how the sort of maritime technology industry works. That's a whole package that I think is hard for anywhere else in the world to compete with.
So for the businesses especially, this is a fantastic opportunity. I think one of the only ones in the UK where businesses can come and have access to an autonomous vessel free of charge to trial and develop new technologies, one in how we operate autonomy within a port environment and offshore, but also new sensors and new technologies to enhance and make an autonomous platform useful, maybe through scientific work, oil and gas and defence. So it's a fantastic opportunity for businesses, and again for the science as well. New sensor technologies to be developed and trialled on autonomous platforms. So a great opportunity for Plymouth and the UK.
This vessel is an unmanned surface vessel built by L3 Harris in Portchester, delivered to us here at the University of Plymouth. This vessel is called USV Cetus. USV Cetus, in Greek mythology, it's a sea monster. In Latin, it's the origin of the term Cetusian, and it also means unafraid of the sea. So this is the boat. The boat is divided into two sections. We've got the engine bay at the back, and then we have the payload bay at the front. The boat is aluminium hull construction, aluminium monocoque, carbon reinforced plastic hood at the back there. See, it's beautifully laid out. It's super neat. They've done an amazing job. It's a 35 horsepower Yanmar diesel engine. It's a pretty standard marine setup, but it's been very, very sort of nicely apportioned. There's a diesel jet drive. It's on a centrifugal clutch. There's no gearbox, which makes it quite a simple system. It's got a big, fat, upgraded alternator here to give you a lot of extra power for payloads. It's got an air conditioning unit for operation in hot climates. Fully waterproofed electronic section, and you can actually operate certain aspects of this from inside here as well, which is quite good for test and diagnosis. This central section is the retractable mast. It's got an actuator here and a great big kind of piston, if you like, that goes up and down, and that's what we mount our instrumentation on. And they're all down here. Under this section, there's basically a large moon pool. So that's a section of the hull that's been cut out. The great thing is that, of course, we can retract that for transit, and then we can lower that when we're in situ and we want to do our hydrography. And that then protects a very, very important asset from damage. This is the payload section where we have the dry payload. So inside this container, you can see we have all of our processors and computers for running our multi-beam and anything else that we wish to put into this vessel. So if we're running ADCP or water samplers, all the coordination for that will be done in this section here. This thing down here, you can see this black box is the waterproof housing for the profiling winch, which gives us the ability to profile in the water column, which is quite a key capability to have if you're doing hydrography. This whole equipment rack here actually lifts out and then folds forward, which is really useful for doing installation and maintenance on our IT equipment. This is the shoreside control station setup. You can see there are various components to this. First of all, we have the helm. That's this device here. That's quite similar to a standard remote control unit. You can use that to drive the boat manually. Here we have the user interface, which is where we do our mission planning. We can control all aspects of the vessel, monitor its performance, monitor all the key systems, and turn various things on and off. And this here is the payload computer, which is linking into the Norbit multi-beam control system that's over there in the payload bay. We've got 4 different ways of communicating the vessel. First way is to plug in via a shore cable, which is quite useful for doing certain high-level diagnostics. We have 3 different wireless communication systems for the boat. The first is this one here. This is the DTC mesh radio network. This is a military-grade communication system and can give us between 6 and 30 kilometers range, depending on the elevation of the base station. We then have a Wi-Fi system here, these 2 white antennas at the top, that can give us a kilometer range. And when we have a 4G cell net communication, these 2 white antennas at the bottom that can obviously give us control of the boat anywhere within a cell phone coverage area. The way this works, if we lose one, it will seamlessly switch to another one, which gives us lots of redundancy, lots of backup, which is quite a nice thing to have if you have quite a big, expensive boat driving around in the sea. So this vessel has several different systems for situational awareness. The first and foremost is AIS. That's automated identification system. That's where all vessels transmit their name and their direction and their speed via VHF antenna at the back there, and that gives us a readout on our chart, which you can't see at the moment because we don't have a GPS fix, but that tells us all the other vessels in the vicinity and where we are relative to them and their speed and direction. We then also have a radar, which is very useful in any sort of low light conditions. And the great thing about this is the radar is overlaid on the chart, so we can see a correlation between the AIS and the radar. We then, of course, have cameras. Now, this is a later edition of this boat. It has 360-degree cameras. So we have cameras forward and aft, port and starboard. And we also have an IR infrared night vision camera as well. So currently I can see the forward part of the workshop. If I can switch to the port view, there we are, we can see us there. So eventually the aspiration is to have these on screens all around us to give you a kind of full feeling as though you're sat on the vessel actually driving it yourself. So this here is the payload computer. All of the actual software for running the mission hardware, so in this case the multi-beam, is actually in situ on the vessel. And all we're doing here is we are team viewing in using a remote desktop function into the computer on the vessel, and then controlling the software as though we were sat on board.
Okay, so those are the video overviews. I just want to now go over a few of the key features of the vessel that perhaps weren't mentioned in the video. It's a 4-meter work class survey vessel called the Seaworker 4 from L3 Harris, based in Portchester. You can see the various aspect views there. As we said in the video, it's a robust monohull. It's very much a kind of tractor at sea. It's very, very hard and sturdy vessel. You know, it's a blank sheet where we're going to be drilling things, we're going to be putting brackets on, we're going to be altering stuff inside. So, you know, we're not precious about this machine. It's here to be used and abused, as it were. And, you know, for that reason, it's been built in a very solid manner. It's a single diesel water jet drives. That, of course, has some great advantages over prop drives in that there's far less risk of snagging, and it can also operate in very shallow water. As mentioned on the video, a flexible wet dry payload. You can see that I didn't mention in the video, the great thing about having that removable rack is that you can use every single inch of space inside that payload bay, right up to the very forward underneath the rack. There's going to be equipment crammed into every last corner, and having the ability to pull out equipment means that you can then get access to all of that. Here we go.
here's a picture of some work we did very recently using shore control. So there's various ways of controlling this vessel. You can either set up your base control station on a vessel at sea, or you can set it up on the land. You can set it up either in a building, or you can put it in a mobile station, as we did here. It has various autonomy functions. It doesn't have any high-level autonomy at the moment. We're not using AI to sense and avoid objects, not least because those systems are still very much experimental and aren't particularly, they wouldn't be Colreg compliant. So there's still a human in the loop, but we can set the vessel to do all kinds of very interesting things, on its own, moving around in very dynamic and very accurate ways without human control. However, there is always a human verifying what the vessel is doing to ensure that we are in compliant with maritime legislation.
Thanks, Aaron. I will step in here and just sort of say that this isn't all the investment under the MBTC project hasn't just been purely in the boat in Cetus. There's a lot that goes on around the boat across the partnership and specifically the university. So as this slide says, a knowledge and experience to operate. So whether you are in the marine sector or whether you have not yet entered the marine sector and interested in doing so, there's a lot more to be said than just moving from desk-based innovation than to purchasing a fancy platform and putting it to sea. There's a lot of key experience, a lot of very highly qualified mariners and key relationships and processes. So there is, as it says there on the third bullet, a UK MAS Codes of Conduct. This is not specifically law, but it's something that is best practice, and we all in the community of autonomous platform operators try to ensure we comply to. There's also these links to the relevant water authorities. It's really important that these things are done under strict controls, as obviously one incident could create a massive backward step for the whole industry. So it's really important, and that's part of the offer MBTC has to guide companies through that. So you don't have to learn it all from scratch. And obviously it goes out saying that you have multiple research organisations and universities within this project. So the academic and specialist technical expertise is almost limitless in terms of what it is you want to do and what we can broker in. So a lot of very keen people who are eager for impact to work on what they want to research alongside industry as end users is an important factor here. Best practice has been developed into standard operating procedures. So the SOPs have been developed in-house here at the university in partnership with local key organisations who also use platforms, and the harbour masters and the RN QHM. And we're happy to share those, but the best thing to do is to walk through it with you hand in hand. So that is certainly the best way to access. So what else is wrapped around? So other things are wrapped around in this project. You see a lovely picture there of our coastal marine station at the university. It's still a relatively new multi-million-pound award-winning building, specifically set up to get people and equipment of all kinds of sizes and shapes to sea and expeditionary use and get them back. So we have lifts and cranes, slips, pontoon space, multiple vessels. I won't go on, but it's a significant facility that's very important to getting out to Smart Sound Plymouth and also local waters. So we launched from here yesterday, went round to the estuary, which is outside of Plymouth's immediate waters, and all of these things are very possible. This is another shot from yesterday's survey with a client company. So this is of Falcon Spirit, one of our research vessels. There are a number of research support vessels available through MBTC, not just universities, PMLs, and others, and the Marine Biological Associations. So these are key components to doing anything with these platforms, and important again for the experience needed with the skippers to know when it's safe and not safe to use these platforms. As you can see in the picture in the lower right, we're very pleased that we can fit and specifically specified Cetus to be road trailerable, but also fit on the back of Falcon, so we can improve our steam time rapidly in terms of being able to deploy and get to site and return. And again, another Smart Sound image here. This is just to give you a sort of image. I'm sure many have seen this, but it's inspirational in the sense that this is the kind of level of infrastructure that we're going to be having or already have in Smart Sound. So this is a little bit of vision of the future and a little bit of what we already have, but it's a good image. It sets up the scene for what you could access by working with the project. Okay, so I haven't spent a lot of time talking about the University of Plymouth, but I'd say that it's an important part of the wraparound offer that it's not just about the researchers, it's also about the students. So in terms of tomorrow's talent, in terms of the people coming up These are just a few of the sort of leading areas that are already working with Cetus and working with the platform. We're looking to have it rolled into formal teaching. Students came out on the survey with an MBTC client yesterday, and it's a really rewarding experience for them and the client to work together and build these skill sets. So this list involves navigation and maritime science. So that, as Aram was alluding to, could be things like how we move forward towards advanced autonomy using these platforms, where they make decisions, make maritime navigational decisions. Hydrography and Ocean X, yep, fantastic benefits to more quickly and more versatile and tactically perform survey. Robotics and control, all about not just the mechanics, but the electronics of what's happening on the vessel. And then mechanical design engineering, because at the end of the day, these vessels will be asked to do things like integrate with one another physically, so charging stations offshore, things like that, and how you look at those engineering challenges. Okay, so I'd like to just run us through a few examples of the clients we have been working with as well. So this first example, Sea-Regs Training Limited is a local company here in Plymouth. They're an independent training provider for both leisure and commercial marine qualifications. And you can see the quote there that they found it very useful. So that the purpose of this trial wasn't actually to trial a sensor specifically. It was more so to develop the skills, and for a company that wants to be on the leading edge of performing or providing the skills to use uncrewed platforms commercially, but without being a manufacturer of the vessels or being a end user either. It's a perfect example of how they can develop the curriculum and really put to test those UK codes of practice in real terms. So getting into the minutiae of how small vessel maritime law actually applies, because there's a lot said in very high level documents, but actually each and every small task hasn't necessarily been practically tried and explored. So it's a great opportunity for that company to do that.
Okay, so another client was ReefCube Limited. This was a recent survey we did out in Torbay area. What we were doing was using shore control for the first time, a long distance shore control operation. It was using the Norbit multi-beam echo sounder system to survey the installations that this company has done adjacent to an important commercial site. It was testing an awful lot of new capability, lots of people working together, and it's demonstrated to them the benefit of these systems in how they can increase their reach and the breadth of their operations without always relying on crude craft.
Another company we're excited to work with is another local company here in Plymouth, Silicon Sensing Limited. So they're really at the forefront of developing MEMS-based sensing equipment for lots of different markets, but they're very aware of the opportunity in marine. And a really good point, which is more of a long persistent study, will be the soon fit out we'll have of the AMU unit. You can see pictured there next to their logo, into Cetus, which will provide a constant steady stream of the inertial measurement and inertial movement of the vessel. So you can see as it's pitching and rolling in those pictures and various sea states, this will be excellent data that we can either have students or researchers work with the data and provide valuable information to the company for their development of their products.
And 3H Consulting Limited, which was an organisation we actually worked with yesterday. It's a very fresh image, as Steve mentioned. We were out. 3H Consulting is a marine archaeological consultancy. They are operating at quite a high level in terms of preserving our maritime heritage. So what we were doing is we were using Cetus to do a combined multi-beam and magnetometry survey of a very important wreck site in the Irm estuary. Cetus performed magnificently, and it's really opened the eyes of 3H Consulting as to how these platforms can be of benefit in the heritage sector that doesn't always have huge amounts of funding, like perhaps oil and gas or something like that, but needs just the same quality of data.
Yeah, absolutely. So that's just a few examples, quite a diverse portfolio, and we do have others. So in this slide kind of just outlines some of the stuff coming soon on the project. So in terms of client pipeline, we have some really interesting innovative companies that we're talking to in early and medium stage conversations around things like dual towed sensing arrays, so how we sort of step up and put more and more sensors in, on and towed behind the vessel, and how we can kind of do a bit of data fusion or a bit of like we were saying in the slide earlier about the offshore wind sector, how we can do lots of tasks at once. more efficiently. We're looking at multi-platform campaigns, so where Cetus actually works in concert with other uncrewed vessel designs, whether they be smaller, larger, airborne or waterborne, or possibly even subsurface. We're looking at ways that, including subsurface, actually one conversation, we're looking at ways that we can really step up and look at the system of systems in action. And lastly, it's not all about physical products, it is also about software and behavior. So we have conversations with large and micro businesses and large prime businesses around the behaviors and the software that drives all of this, all very much derived originally from defense, but there's a lot of work to do around refining these behaviors for commercial applications. And there's things like 3H, for example, come up in that last example. There's new, ever-growing new applications for these that require subtly different performance and behaviours that we will work, hopefully, with the manufacturer of the vessel and others to refine.
And just looking at actual future tech developments for the vessel, the key thing to emphasise is that USV Cetus is a blank slate. So it's there for people to, suggest additions to request modifications for, but just to give you some of the things that are very much in the pipeline, we're certainly looking at upgrading to a 5G communications link to give much higher bandwidth. Key thing is the SATCOMs element. Currently there are no SATCOMs, but they are very much on the way, and of course that gives you the ability to do long distance over the horizon operations. The thing with SATCOMs is the current data cost. That's the limiting factor. So as much as the hardware and the technical element, it's about working out the financial models as well as to how that data can be funded. And there's a cost benefit analysis in terms of to be done there. We're putting in an underway real-time water analysis unit that will be constantly measuring oxygen saturation, chlorophyll A, temperature and salinity of water in the surface area around Cetus. We have a combined conductivity, temperature, depth, and the sound velocity and chlorophyll A profiling probe, which is on the inbuilt winch that can profile down to 90 meters, giving us a three-dimensional sensing set. We are soon to be installing a water sampler. That's a 36-point physical sampler that will collect water whenever a particular user requires it. And interestingly, currently it's going to be for surface water only, but we also have a development planned for a descendable extraction point, if you like. So we're going to be able to do a three-dimensional water sampling ability. We also, obviously, you may be aware that Plymouth is very much involved in the marine sort of litter and the plastic pollution question. So we have in the pipeline a large volume water filtration unit. You can't, if you're doing microplastic sampling, you can't just take 200 millilitres. You need to pump quite a large volume in litres through meshes to be able to find the solid particles in the water. That's going to be a unit that's going to be constructed soon. We have a high spec MET station that's going to go on the vessel. We have a much higher resolution multi-beam also in the pipeline. And this last one is really interesting. Currently we have one sort of base control setup, but we're also looking at building a second one, either at the marine station on campus, which will be a bespoke facility for splicing into the vessel once it's been launched. Say you might tow it out of the Plymouth Sound using local control, and it will be handed over to a shoreside control center within one of the facilities that we currently operate.
Brilliant. Okay, so I'm conscious of the time, so we're nearly out of time, but we are luckily nearly also out of slides. So just to summarize the offer that the project, the MBTC, is offering companies and Cetus is providing. This is access to a state-of-the-art USV. This is freshly off the line, if you like, from one of the leading providers globally in terms of these platforms, and we have also got a small network of other end users, notable high-profile organisations around the world who purchase the sim model of boat. So this is really a very serious piece of kit that's available for free for companies, large and small. This is, as we've said, an opportunity to de-risk and demonstrate, prove technology in unmanned operations. It's not about inventing necessarily new things. It might be about taking things that already exist and proving that they can be operated and deliver without anybody on board, or perhaps in the marine space for the first time. This involves, like I said, a dedicated team to plan and organise and engineer to operate these sea trials. There's a lot. The bulk of the work for each of these trials that we've shown in the case studies all happens in the front end. So before the actual survey day, there's an awful lot of work in the run-up, and this is what's all available as well under this project. It is an opportunity to try before you buy. Many of our end users and clients have looked at this as a way to actually see whether it's worth either developing their own, purchasing their own uncrewed platforms, or working with supply chain companies that we can link them with in the region who do provide either design and build their own or in other ways provide services using these platforms. We've talked about the wraparound from the wider organisation based beyond university and all the companies listed in the project and on the right banner there. And again, extra benefits. There's some funding available through the MBTC, and there's also a whole network of innovative businesses that you could be introduced to if you didn't already know. So fantastic opportunity to build your contact base and innovate that way. As I said, it's free at the point of delivery to eligible businesses. So the next question is, what do you do next? I specifically have shied away from getting into the minutiae and detail around eligibility and how these questions are answered. Partly because it's all completely on a case-by-case basis, but regardless, whether you are a micro business, a sole trading individual with an innovative idea, or whether you are a large tier 1 prime can see real opportunity to get involved with this project, I would urge you to get in touch with us and do so as soon as you can, because this project is rolling until July 2021. And in terms of deployment time and the run up, particularly for the larger activities we've described, it's all in the planning. So that takes us to this next slide for this webinar. So it's at this point I'd like to hand it back to Chelsea to let us know what questions may have been asked through this course of this presentation, or for anyone who is on the line to offer up your ideas if you'd like to talk them through live.
Thank you, Steve. So for those that don't know, there is just a live Q&A button to the side that you can open and type your questions in. We've got 10 questions already added. I am conscious of the time, so if I think the question's been answered, I will skip it. And then at the end, I'll just get Steve and Erin to do a quick run through and just check I haven't skipped any that wasn't answered. So the first question is the vessel safe in all waters, or will it need to be used in pre-agreed waters?
Sorry about that, Chelsea. We've just got somebody coming in the room at this end. So can you repeat the question again?
Yep. Is the vessel safe in all waters, or will it need to be used in pre-agreed waters?
Well, you cover that now.
So ultimately, it depends on who controls the water space. I mean, sorry, there's two different parts to this question. I mean, there's safe and then there's permitted. These vessels are very safe if the operations are run correctly and if you have the appropriate support boat cover. So if you're doing uncrewed vessel ops very, very close to rocks in very crowded waterways, you have to make sure that you have the ability to respond and intervene and rescue that vessel within minutes if there's a problem. If the vessel is way out to sea, offshore, in nowhere near any shipping lanes, you can have response times for a support vessel of many hours. In terms of permitted waterways, obviously any sort of harbour limit will require permission from the harbour authority, and it requires good relationships to be built with the harbour authorities, because quite rightly a lot of these organisations are quite sceptical and conservative in their view of this technology. And I think as long as you build a good working relationship, you make clear all of your operational procedures, you ask their advice, these operations can be run very safely and very efficiently.
I would just add to that, and whether that question is generally across like use of platforms or Cetus specifically, Cetus has a number of fail-safes built in, obviously, as you'd expect. So both in the remote helm unit and on the physical vessel itself, you can see in this picture where the hatch is lifted, there's a small red cord hanging where the mast section is. You can see it connect just above the EU flag. Those kill cords, you pull that, the vessel dies, and it goes into a static safe mode. And will stop doing whatever it's doing. And likewise, big red buttons all over the place in terms of control center, shoreside or on the support vessel. And as Erin said, it links back to what we were saying in a prior slide. The relationships with the key authorities is key. It is key here, and not just university, but the wider partners possess all those relationships.
Okay, so the next question is, would we be able to use Cetus this summer for a new test? What would the last date be that we could use Cetus this year?
I'll take this one. I'll say in theory, yes, it's available to use this summer. And it depends entirely on what it is you would like to do and how and what's involved. Theoretically, if it was something that was doable with a small support crew, and the company was agile enough to be available at short notice, almost on call, we could stretch that right into sort of October, November time, depending on conditions and what it is. If it involves a lot in our students or our research academics, things do become tighter once you get past October, naturally, because of the teaching schedule that picks up around that time. It doesn't make it impossible, but it does mean that it's more of a scheduling challenge. But yeah, short answer is absolutely, the sort of caveat is it depends what it is.
And I'll just add to that as well, if that's possible. I mean, the vessel can run all year round. It's however, there are sea state limits. We wouldn't really want to be out in anything greater than a force 4 to 5. And indeed, if we were doing any sort of data acquisition, it probably wouldn't be suitable. So it does depend very much on what the project is.
Yeah. Okay, I'll do this next question because more than one person would like to hear the answer. Do you charge for using Cetus and the support you provide before and after?
No, we do not, but there are eligibility criteria around that offer. So this is a project funded by the European Union to support economic growth in the county of Devon. So that means that we are geared up to support companies located in Devon. That doesn't mean they're necessarily all physically. There needs to be a physical presence in the county. And rather go through it in long detail here, I think it best to reach out after this presentation and have a conversation with us, because as long as we can derive the physical benefit and economic impact in the county, it's technically eligible. But that is a broad and vague statement to make that requires a lot of work through. But no, the cost and free at point of delivery is to a certain reasonable limit. I can't quote specific goalposts in terms of days or hours access you would have, but I think that the best way to describe it is you are to address an innovative challenge, and that innovative challenge could iterate. So we could do one thing and then that could lead to another study that expands the innovation further, so you may have a second bite of the cherry. But it also needs to be reasonable. If a company asks for 2 solid months of campaign time using Cetus, it wouldn't be viewed as a value for money proposition by the funder if we are looking to assist a number of companies and make the broadest possible impact. I hope that answers the question, but again, please pick it up with me direct afterwards if it doesn't.
Okay, so next question that's also been liked is, how long does it take to prepare from the first request to getting your test deployed on Cetus?
Well, there's 2 parts to that. There's, of course, the eligibility criteria paperwork side, and then there's the technical side. So I'll hand the first point there over to Steve.
Again, it could be a very quick process. In a few short meetings, you could have the MBTC carries with it a penalty of paperwork, I'm afraid. We are very auditable to make sure that we are delivering this value under what is public tax-paying money in the EU, and there is an organisational needs analysis paperwork that needs to be completed by both the knowledge exchange person on the project, would be myself or a colleague on the project, and the company. So that's an agreed narrative, a lot of eligibility as we've already described. So checking eligibility and also working through what it is the company ultimately wants to achieve, and working together with our experts like Erin and others around perhaps the journey to getting that outcome isn't as clear as what you might think when you approach us. It might be something slightly different. So it could be, I'd say, a week or 2 to get to a point in conversations where you know what it is we roughly want to do. It could be another week or 2 to pull together some kind of plan and pull in the necessary resources and start to schedule the work. So you could, after a month of engaging with us, be prepared to go into a trial, or like we said earlier, if it was this summer, potentially sooner. It does really depend on what it is you're looking at.
And from a technical perspective, how long does it take to prep for a trial? The vessel can be mobilised within an afternoon, effectively. You know, whether or not it's ready for what the client wants depends on what they want to do. So if what they're doing is very self-contained and they have done much of the integration work themselves, that can be very quick. If it's something very bespoke, the vessel needs modification, it might take a lot longer, case by case.
Okay, brilliant. I'll do a couple of the more technical questions now. Do you have LiDAR capability?
LiDAR.
No, currently not. However, we have had some preliminary discussions to look at installing that, and there has been precedent to actually install the LiDAR systems on these vessels for other clients of the company that made them. So the expertise is out there. It will just be a case of join the dots with the requirements and the funding streams.
And I'll just add that the answer to the question of is there a LiDAR sensor on the boat is no. As Aaron said, this exact model has got LiDAR on it with another owner. So we know it'll be relatively quick to fit and integrate. And if we had a project or a company that was interested in doing work that involved LiDAR, one of the things that the university and the project can do is we can talk to people who produce sensors like LiDARs, and we can look at and exploring ways of mutual benefit where we can quickly get our hands on one. So it's not, anything is possible, and there is a sensor budget on this project as well. So there are ways and means that we can do that if the project calls for it.
Okay, so next question is a radar reflector installed? Is the vessel visible to others on radar as well as AIS?
Currently, there is no radar reflector. However, I've been on another vessel and seen that this vessel does actually have quite a reasonable reflection signature. So in terms of whether it needs a radar reflector putting on, I think would depend largely on where it was operating. So if the skipper who was running this felt that it needed a greater radar signature, we could certainly put one on, but it didn't come with one installed, no.
Okay, so let's go with this one. Did you tow the Magnetometer from Cetus? If so, how was this deployed and or recovered?
That's a very good question. Magnetometers are deployed from sort of crewed vessels, generally are flown, if you like. I don't know how many of the people watching this know that. So you regulate the height of the magnetometer by the speed of the vessel and the cable you put out. And that means if you stop, the magnetometer sinks to the seabed. Because we were doing a very, very shallow magnetometry survey, we actually buoyed the magnetometer. So the magnetometer was on the surface. The seabed was only sort of 3 or 4 meters below, so that was fine, and that means we didn't have to worry about the magnetometer, crashing into the seabed. We actually used a small tender vessel to attach the magnetometer once we were in situ, and we were towing it, I believe, on a 15-meter layback.
Great. Another question here. What distance can it go between fueling? What happens if it runs out of fuel or breaks down?
So the vessel can operate at a kind of nominal cruise speed of about, well, it has a maximum speed of about 6 to 7 knots, an economical cruise speed of between 4 and 5 knots, and it can operate like that for up to 2.5 to 3 days. I mean, in terms of what happens if the vessel runs out of fuel, well, obviously it will stop, but if you get very real-time data coming back, you know exactly what the fuel usage is, and it's part of your diligent project planning to make sure that that doesn't happen.
Just to add to that and to pinch the quote from Professor Jones in the video, one of the things that makes us a bit of a Goldilocks vessel is, 2 to 3 days in terms of persistent use isn't very long, but it's long enough to test that persistent use of something is possible. We specifically selected that, and when we were weighing up the balance between power and longevity, because a lot of the more persistent, longer application platforms, other models from other manufacturers have much more limited power and maneuverability and responsiveness, whereas obviously this vessel is developed to be using it no longer than 2 to 3 days. But
I mean, that's a very good point from Steve there. You can make, like I said earlier, you can make sort of solar powered and very energy efficient vessels, but because of the diverse range of payloads that we're going to be putting on this, we needed the ability to give it lots and lots of power when needed. So having an internal combustion engine, whilst not perhaps the future, if you like, certainly in this case gives us the ability to power heavy payloads.
Okay, next question. Where have you typically placed the base station setup on previous deployments? Specifically, do you feel confident operating the vessel without eyes on yet?
That's a very, very good question. So the early deployments were all done with a base station on the support vessel in very, very close proximity to Cetus. That was obviously a prudent thing to do if you're not sure about a system. We've then done, as you saw with the ReefCube's deployment, we went to our first shore-based control station where we could actually see the vessel, but we discovered that immersing yourself in all of the data feeds, eventually you gain a kind of sixth sense of where the vessel is and what it's doing, and confidence grows. It's a learned skill to be able to pilot these things completely from remote data feeds, and you have to ease yourself into that world cautiously. You have to be very conservative about the estimation of what you are safely able to do, but having done that, I believe that you can gain exceptional situational awareness from these systems with the correct approach.
Okay, next is my favourite question. What happens when the vessel suddenly meets a mammal or human in the water?
That's also a very, very good question. So we have on this vessel 360-degree cameras. We also have infrared cameras, so we can see warm objects in the water in front of us, which is actually not something available on manned vessels. So if there was any doubt about the fact that there could be a marine mammal or a human being in front of the vessel, we would of course stop straight away. We would take avoiding action and ensure that life and property was protected. You know, there is also the fact that this vessel, it doesn't have a propeller, and it's also quite slow. So indeed, worst case scenario, there was a collision between this vessel and a large marine mammal, for example. The chances are, you know, it wouldn't cause a major incident. But that said, we would do everything we could to avoid that, and I believe that we have a situational awareness to avoid that.
And certain upgrades have been made by the university. So there is a marine microphone and a loudhailer on the boat. There's an ability to basically communicate in audio with people immediately around it. But the real answer to that question is, when it comes to swimmers in the water, for example, we would if all of this is used correctly, we shouldn't get very close to one. It's obviously designed and coloured in such a way that it's not going to sneak up on anybody. It's certainly loud when it's running, and that again, in terms of marine mammals specifically, is a noise element that makes it probably not very stealthy in terms of marine mammals either. And as Erin said, there's no prop, so you wouldn't be causing any damage.
Okay, we're running slightly over. Did the two of you just want to have a quick scan over the Q&As and check I haven't missed any questions?
Yeah, sure. How do we do that, Chelsea? Should we stop sharing the presentation, or do you have a way?
No, you can still share the presentation. A bar should come up on the right-hand side that says Q&A.
Nope. Oh, here we go. Q&A. Here we go. Yeah. Okay, so
where do you remote helm from?
We can do the helm question.
Yeah, so where do you remote helm from? Is it the marine station, or do you need to be alongside in the vessel with line of sight? So in terms of the operating procedures, we've developed 4 modes of operation. The modes are support vessel control line of sight, shore control line of sight, support vessel control over the horizon, and shore control over the horizon. And there's a whole bunch of criteria in each of these modes of operation that have to be met for you to operate in each mode. Obviously, support boat control line of sight, the requirements are far less than the most demanding, which is shore control over the horizon. So you have to put in place lots and lots of kind of safety protocols depending on which of those modes you are operating within. And within the operations manual that we've produced in the university, it's all laid out there as procedures that we follow. What else have we got there, Steve?
I'm just seeing if there's anything. Okay.
Okay, how long will this project run? We've done that.
We've done that. I don't think there's any we haven't addressed, Chelsea, and none that are leaping out.
Okay, brilliant. If anyone has any further questions, I will just get Steve just to put up his and Erin's contact details there. Please feel free to contact Steve and Erin direct if you are interested in using the vessel or want to find out any more information. And please feel free to contact me if your business would like to be part of our Marine Tech webinar series, or if you're interested in attending any other series. With
Thank you, Chelsea. And just to say, so that's our contact details. I hope everybody can see on the screen there. And lastly, just to say thank you to everyone for attending, and also just a thank you to Chelsea and the council's Oceansgate team for putting this on and putting it all together. You can see Chelsea's details there.
Okay, brilliant. And thank you to our presenters, Steve and Erin, today. And with that, I will now draw the webinar to a close. Thank you for everyone for attending.
Thank you very much.
Thank you, guys.